Welcome to the AVL Simulation Podcast, where engineering missions take off. Join us as we navigate the evolving universe of digital engineering and simulation in the automotive and energy industries. Explore the forces shaping the AVL simulation software suite and hear how pioneers across the globe use it to outpace competition. Strap in. Our mission begins now. Welcome your host to today's episode.
Today, we are heading straight to the heart of simulation, the place where AVL software is imagined, engineered, and evolved. I'm Max Sommer, and my guest is Jürgen Krasser, Skill Area Manager for Software Development at AVL's Advanced Simulation Technologies. As the head of development, Jürgen has witnessed the journey from standalone simulation tools to cohesive cross-domain platform. We'll explore what makes AVL software truly engineer-driven, how simulation is expanding into the new industries, and what it takes to lead a development team at the intersection of physics, code, and customer feedback. Let's get into it. Let's think of AVL as a technology universe. Jürgen, where do you find yourself in this universe?
As you know, AVL is structured into three strategic business units. It's the engineering business unit, then we have instrumentation and testing, and then there is advanced simulation technologies. And this has been my home for almost 30 years now.
Impressive. 30 years with AVL in simulation. I think some of our audience might think, wow, 30 years ago, advanced simulation. Maybe give us a historic overview of what happened in this last 30 years with simulation at AVL.
Yeah, I mean, we started off by actually taking the in-house tools that were developed in the engineering department and we started to commercialize them.
Mm-hmm.
That was, I would say, the first phase going into the early 2000 years, and then there was a big growth phase where we expanded our teams quite a bit. Also going into our Zagreb and Maribor offices and Ljubljana offices.
So in Slovenia and Croatia.
Exactly, yeah. So that we consider Graz, Slovenia and Croatia as the core of our ASD development. And after having this growth done, we were actually at the position to go into consolidation. So actually to consolidate all our products into one common platform.
Okay.
So this was a big undertaking. And I'd say we are now entering into the fourth phase. That's going into delivery models like software as a service and also actually quite brand new interaction models with the software like conversational user interfaces. And not to forget, I mean, AVL is a technology company. We are also going into the new technologies with our software to support the development of electrified powertrains. We're also going into industry, energy industry. And that's our current work.
And we will deep dive into our portfolio and into the product solutions that you are working on a daily basis at a later point in the podcast. Now we are still in the warm-up phase. So Jürgen, give our audience an idea of what your role at a simulation at AVL is.
Well, that's quite easy.
Okay.
Well, I'm responsible for the development of the software products. So managing the teams, the processes, making sure that the releases get out in time and quality. Yeah, that's it basically.
So you're head spearing the
So
the
I'm
development.
head of software development.
Head of software development. That's great. We ask every guest at this podcast if your job had a nickname, what would it be?
Well, I mentioned we had this big consolidation phase, and so basically that was something that probably would have coined a nickname for me, and that's Mr. Simulation Desktop.
Mr. Simulation Desktop. Also, we will get into that a little more at a later point of this podcast. But I think everybody should remember Mr. Simulation Desktop, as it was really a big milestone and still is a big milestone for this company. What got you into simulation/software in the first place? In the first place.
The first place, yeah, actually, you will not believe. I mean, that it was in high school.
Mm-hmm.
I was actually intrigued by the idea to use math, because I loved math, to predict what's going on in reality. So that was it, basically.
A classic high school motivation.
Yeah, and I only found out maybe, was it 5 to 10 years later, when I was into hydrodynamic bearing simulation at AVL as a student, that, well, that's it, I'm here. And I stayed.
So still you're kind of pursuing a high school dream, could you say that? Is it still a little bit of that fire in you?
You could say so, yes, you could say so. Although many new other aspects came into the job in the meantime, I have to say. So I could have never imagined, I don't tell you how many years ago, what I would be confronted with and what I would see in these decades. So that's unbelievable. The industry changed so much. You cannot compare what we did back then to what we are doing now.
Beautiful. Looking back at your professional development, what steps did you take to shape it? Were there any decisions that made the greatest influence, and how did they affect your outcome?
Wow. That's a bold question.
That's a bold question. Every career is kind of on a path, and it takes turns. Tell us about the big turns in your career.
I wouldn't say there were so many turns. There was a dream that I mentioned before. So the obvious first decision was to go for a degree in applied mathematics.
Okay.
And that's what I did. And actually, already at the end of that studies, I came in touch with AVL as a side note. And then afterwards, I added a postgraduate program in business. And that's basically laid the foundation for everything. And then along the way, it was a lot of learning new things, always being open to take new challenges, learn new concepts, get into new topics, be it in the software engineering area, be it in the artificial intelligence area, be it in the process management area or business area. So I always tried to develop breadth of knowledge. Yeah. And at the same time, I always found it very important, and I really have to stress that you need to also have some depth. Mm-hmm. So meaning it's not enough to know a little bit about everything. In some key areas, you have to be knowledgeable. You have to know more. You have to go to the depth and make your fingers dirty. Mm-hmm. So in particular, if you want to lead a bigger team, you have to know what the people are doing. Yeah. And from time to time, you have to sit down and do some coding and see, okay, this is how it works. Mm-hmm. This is how the environment really works for them. This is the problems they see, etc. So it's always this combination of breadth and depth that you have to pursue to stay connected and to stay relevant. Mm-hmm. Yeah.
I've had the pleasure to work in your area or in your environment for a little bit, and we had some touch points quite frequently in some topics. And what I found is exactly your depth of knowledge in various topics. But then I also thought it seems like you are good at saying no. I will not get into a topic because I will not, this is not my area maybe, and I will maybe just know headlines of it. How has that worked for you to pick out the topics that are relevant for you. What kind of metric or what idea do you have behind what topics you really want to know in depth and go put your make your hands dirty, and what topics might not just be worth touching with the time at hand?
Well, I'd say I'll never become a chemical engineer. So that's probably a topic where I rather rely on members of my team.
Yes.
And of course, everything that's really connected to mathematics, to software engineering, touches me more, and that's where I easier go into the depths. Of course, yeah.
Now, you work in software development. You laid out your career path, your way to become the head of development of simulation software at AVL. What parallels between your career path and simulation software can you find?
You mean software development?
Software development,
yeah. Well, you have to have a vision.
Mm-hmm.
You have to know where you want to go. And then basically you have to be agile along the way. That's it. And of course you have to make a lot of decisions. Maybe there are more decisions to do during software development of a sufficiently complex system than the decisions you have to take for yourself. Obviously, the cadence of decisions is it's much slower for your personal decisions, but of course they are more severe. And as I said, this agility along the way. I mean, you shouldn't be stubborn. Okay, that was my vision. That's where I want to go.
Yeah.
I mean, if that's not feasible, you have to adapt your goals.
Yeah.
And that's basically both the same for life and software development.
And not only the goals and the vision, but the way to get there, right? You stay
have to
nimble
adapt
on
it,
that. You have to adapt to it, and that makes great sense. As mentioned before, we will now dive more into the software itself. Who better than you can give an overview of our software portfolio? What do we offer today? But again, I think it would be interesting for our listeners. Where did we start with our portfolio? Where is it today? And where do you see it tomorrow?
Well, as I mentioned before, we started with a set of tools that I shouldn't say that, but inherited from an engineering department. And of course, this set of tools was dedicated to IC engine development, because that was AVL at that time.
Yes.
And
around about
30 years ago.
30 years ago, okay.
Yeah. And and in the same manner as AVL developed, of course, also the application of our software grew, and also the areas where we developed our software for. So we went into vehicle engineering with Cruise, that we added in the early 2000s. We started, by the way, with Fire. We started with a set of tools that later was named Excite.
Yep.
And we started with Boost. So we further developed the software into new areas, whole vehicle development, or CFD code became much more versatile than it used to be. I mean, you can use Fire for external aerodynamics, for fuel cells, for electrolyzers. The same, of course, we did with Excite. It grew from pure IC engine applications to whole powertrain applications to wind energy. And maybe the biggest change or expansion we saw in Cruise, which became a real multi-physical system simulation environment, not comparable Cruise as Cruise M, not comparable with its predecessor Cruise. We also have added Model Connect as the co-simulation platform, and in recent years we also went into ADAS scenario-based testing support tools with our scenario designer and scenario simulator. So that's actually, it grew quite a bit.
So CFD, you mentioned system simulation, and NVH, multi-body dynamics, I think would be the good categorization. And then the co-simulation platform. And it all is still growing into new applications.
Exactly, yeah. As I mentioned, energy and ADAS. So that's basically the areas that we are going now. And of course, supporting this whole electrification endeavor of the automotive industry. Not to forget, I mean, automotive is still the core business.
The core business. I think this is also interesting to everybody, that some of these software solutions are absolute leaders in the automotive industry, in the development.
That goes without saying,
I mean, just that everybody understands, that we have a saying here that there's almost no car on the streets or no vehicle on the street that hadn't had any touch with AVL simulation software, and we are very proud of that. And I think this global footprint is also worth mentioning. Which brings me, when we talk about successes or our footprint in the industry, what do you consider to be our greatest strength?
Well, it's basically the knowledge of the physics. Yeah. So we do not have just a team of software engineers. We have a great team of people with physics knowledge in various areas, and to be able to transform this knowledge into simulation software is our biggest strength, and at the same time also to be able to apply the software for real-world problems. So to bring all these together, that's actually, I would say, our biggest strength that differentiates us quite a bit from other suppliers.
And probably this application knowledge, know-how, expertise also stems from the structure of AVL with the engineering. You maybe dive into that a little bit, this collaboration or the interaction between or within this great company.
Yeah, it's obvious. I mean, AVL is a technology company, and it's in the DNA of AVL, this pioneering spirit, this engineering, and the fact that we are in AVL, of course, gives us good connections to people working on top-of-the-notch development projects, and so we get a lot of requirements, of course, from there, and we get a feel where the industry is going to be able to prepare ourselves with our tools to support this.
Yeah, that's great. Now, the industry is struggling with a shortage of resources. It is in these times you hear that resources are really a topic. Yeah. How do you deal with these challenges? How do you set the right priorities within the development of your software? There's one saying that I always enjoyed thinking about and also discussing with you. There's the right to play and there's the right to win. So with resources that might not be endless, how do you achieve this right to win with your software?
Yeah. I have to start because I always say the same thing about the shortage of resources. Shortage of resources is in the nature of business. If you're not short of resources, you're not in business. But coming back to your original question, I mean, right to play, right to win. I mean, of course, that's what you have to navigate. Yeah, and we actually do that. We structure all our activities basically into 3 categories. That's, on the one hand, it's whatever we do to keep our customers happy. Our existing customers happy. When they have enhancements requests, we, of course, feed them into our development pipeline and then deliver the features as requested by current customers to make their life easier and to make their processes more efficient. The second thing is this right to play, work on sometimes call it infrastructure. So that's basically to keep the technology abreast. Yeah. So that also includes, by the way, a topic that is becoming more and more important: software security.
Yeah.
Yeah. We're getting more and more requests from our customers to prove that we are delivering software that actually can be deployed securely in their environments. But also other things like supporting GPUs, to go to have state-of-the-art hardware support. So this is all the work we do on the infrastructure side. And then there's the third part, that's the right to win part. That's where we work on differentiators. That's where we work on attacking new challenges, new issues, finding new application fields for our software, where actually new business actually can also be one. And so we are actually navigating this triangle to really balance the budget allocation between the three.
Always with and you can hear when you listen, with the customer in the middle.
Of course.
Customer-centric in the middle. Now, obviously, there is a competition. It wouldn't be a market. It wouldn't be a market. It wouldn't be business if there wasn't competition. Maybe a bold question, but what makes our software special? What differentiates it?
I mean, there is no company like AVL, and that's what makes us special. You know, this is really this deep knowledge of the engineering, the application of the software in engineering projects, and these feedback cycles that we get, these short feedback cycles that we get, that really makes us special. These connections to the engineering, the connections to the testing. Well, that's it basically. Yeah.
You mentioned earlier the consolidation phase when talking about the historical development of advanced simulation at AVL. And you told us that your nickname within AVL would be Mr. Simulation Desktop. Now you have to tell us, what is the simulation desktop and what does it have to do with the consolidation phase?
The simulation desktop is the platform, a software platform that all our products are built upon. So if you take Cruise M, if you take Fire, if you take Excite M, they are built on the user environment of these tools is built on the simulation desktop platform. The platform provides all the basic services that are needed to build a simulation software environment, like the data management, the parameterization of the models, the case management, the variant management, job management. So simulation job management. If you want to run 100, 1,000 different variants of a model, this all needs to be controlled, managed, and there is also material database inside this platform. And finally, all the visualization of the results, from 1D visualization, curve visualization, to topology-based flow diagrams, to the 3D visualization of 3D results from flow simulation or structural dynamic simulation. That's all built into the simulation desktop.
And the motivation behind the simulation desktop, why you have this successful running individual tools, have a red logo and a blue logo. Why do you put all these tools together?
We thought the green logo would be nice. So we put everything together. No, joking aside, of course, there are commercial reasons for that, economically reasons for that. By this, you can obviously gain a lot from software reuse. And software reuse is not just saving money for development, it's also being able to deliver higher quality. The more often you use the software, the better it gets.
Yes.
Yeah. And the other aspect, of course, is its consistent user experience that you can deliver this way. So switching from a system simulation tool like Cruise M to a 3D CFD tool like Fire M is not like going to a different planet in the AVL universe.
And this seamless approach between 1D, 3D, between the different worlds or the different approaches of simulation. Tell us more about this. How can engineers maybe collaborate better? How can one engineer actually maybe jump from 1D to 3D? If I understand right, this is also the idea behind that you have a seamless approach.
I mean, it's as easy as it can get. You start our simulation desktop on your computer, and then you can either start working with Cruise M, you can start working with FireM, all within one project file. So you can have multiple models within one project. They can share the data. You can couple the simulation. You can reuse models from Cruise M in FireM. That's basically it. And the good thing is you really have the same user experience. So it's the same thing. It's always the same thing. You build a model, the same paradigms that you find everywhere. So once you're knowledgeable in Cruise M, you can become a CFD engineer. I wouldn't say in a day, but you can start very fast and get to speed quite fast. And we are also working a lot on making it easy to get into the software, using generative AI to help you. And that's basically the way we're going. Yeah,
I really think we must remember this bold headline: become a CFD engineer in 1 day for our marketing team. That might be something they want to pick up, all enabled by the simulation desktop. But jokes aside, not really jokes aside, there is a almost running gag when you talk to software users, software engineers, software developers. Is it a bug or is it a feature? So tell us, can a bug actually be a feature?
Maybe. I just haven't met any.
Okay.
So I have to say, I mean, if it's a bug, it's a bug. So we must be realistic about that. Of course, there are corner cases, and that's probably the reason for all this discussion. I mean, software usually is designed for a particular purpose. And as in particular simulation software is quite flexible, and users try to explore new things.
Yes.
It can happen that they use the software for something that it wasn't designed for. Yeah. And then, of course, unexpected things may happen that the user considers a bug, and the developer says, well, that's the feature, but for the different use case. Yeah.
Understood.
So, but I guess these discussions are useful and fruitful because they can trigger new ideas where to go to.
Yeah. Let's stay with that. It's obviously, as you said, it's in the nature of an engineer to try out things, and also with the software, which kind of is a tool. As it is a tool, you try out what all can you do, and can I push the limits maybe, or can I go into that direction? When a customer reports a misunderstood bug, or when a customer reports something back to the headquarters and where the development takes place, how do you handle this maybe interpreted bugs by users?
Well, we take them seriously. That's the most important thing. And I mean, first of all the bug reports that come from users are treated with highest priority.
Okay.
So we have clear KPIs, how fast we have to treat them, and how fast we have to bring resolutions into the software through maintenance releases or new enhancement releases. But of course, I mean, if something new is tried out by the customer, we talk about it and see whether this might be actually a new application field that we want to go into.
Yeah. Now, kind of wrapping up this section of our software portfolio, the products behind, the methodology, customer support, etc. I want to ask you, what would be the greatest compliment a user could give you?
Yeah, as with any software engineer. And I mentioned it actually several times before. You made my life easier. You made my job easier. You saved me a lot of time.
Yeah.
So that's basically it. If we hear from a customer, well, it took me 3 days before this feature and now it's 5 minutes or half an hour.
Yes.
I mean, that's of course what you want to hear, and that's what you are for and what we are working for.
Beautiful. Now we are kind of getting into the last section of this podcast episode. Jürgen, you've worked in software development for several years/decades, progressing from a student to head of development. In your opinion, what makes a good developer, and what qualities do they need?
It's actually quite simple. They need to be smart.
Yes.
And they have to get things done.
Okay.
That's it.
That's it.
That's it.
So maybe elaborate a little bit why exactly these two factors for you are essential.
Yeah, of course. I mean, our problems are hard to tackle.
Okay.
So you need to be smart.
Yes.
You have to find your ways through the problem space, look for solutions, and that's basically what you have to do. And in particular, when we talk about our areas, that is quite a little bit scientific.
Mm-hmm.
There is a danger that you lose yourself into the details, and then you will never get anything done.
Okay.
So you might be the smartest guy in the world,
Yeah.
but never deliver anything.
Yeah.
And of course, that's not desirable as an employee.
No, it makes complete sense, and I think is
So
quite also catchy to remember, and maybe for our audience also a new perspective on if I evaluate future prospects is smart because complex topics, but getting stuff done at the same time might be the formula for high performance.
Yeah. One thing, yeah. And you have to be willing to communicate with users.
Yes.
That's also very important.
Yeah. Great addition.
Mm.
So you started as a developer. We have heard that in the early days, and you're still getting your fingers dirty, as you mentioned, in particular topics where you feel like you need to have deep knowledge to also lead your teams. What changes have you noticed on the job of a software developer, and how do you think the job will change in future?
Well, I mean, looking back, as I mentioned before, I mean, everything has changed. This industry of software development 30 years ago, compared to today, this is Stone Age. And we are now in the AI age. So all the tools have changed dramatically. The processes have changed dramatically. Automation is key in everything you do. And so that's from the environment that we're seeing. Of course, also the processes have changed a lot. We started off with waterfall processes. Everything has to be specified to the last details before you even start to type anything. And this was, of course, also kind of paralyzing in many aspects, because how do you want to specify things where you don't really know where to go in detail? Yeah. So, and of course, I mean, but this is also something that's been around for quite some time, this agile development, working in teams, interacting with the customers on a, if not daily basis, but or the users, which in our case, fortunately can be in-house users, on a daily or at least multiple times per week basis. And of course, recently a lot is changing with adoption of the new technologies coming from this generative AI wave. I should rather say it's really rolling fast and growing, and you have to get on top of that wave. That's very clear for me.
let's stick with AI here just for a second. In which fashion and form does it change the way you are working on a daily basis and also changing your products?
Well, obviously, I mean, there are so many helpers now around based on large language models. I mean, be it GitHub Copilot that helps you in coding, suggests changes, refactoring, writes tests for you. So this is really a productivity booster.
Okay.
And this is actually what you really must make use of as a developer. And so that's basically these productivity tools. And I mean, looking up something in the internet nowadays, what took you maybe a few hours before, you get answers now compiled, summarized by these tools in a fraction of a minute.
Yes.
Yeah. So using this is mandatory, obviously. Otherwise, you're just not fast enough. And well, the same happens with our software, of course. So what we are doing is working on a new style of interaction with the software. We call it conversational user interfaces. So the goal is that in future, and we already have with ChatSTD, first versions of ChatSTD, something in our tools. The goal is to be able to talk with the software just like the two of us are talking now.
Yeah.
So this will speed up the productivity a lot, of course, because we're again back to CFD engineer in the day.
Yes.
So you don't have to learn that long, and you don't have to learn how to handle the tool. You just tell the tool what you want to do, and it should do it then based on your intentions that you can express in natural language. So that's our vision. Yeah.
Jürgen, thank you so much for this conversation, and I hope that we can sit here and talk about the next phase of advanced simulation technologies at AVL very soon. Thank you very much.
Thank you very much for giving me the opportunity.
Thanks for joining us on the AVL Simulation Podcast, where engineering missions take off. We hope today's journey through the world of simulation sparked new ideas and perspectives. To keep up with future episodes, subscribe wherever you get your podcasts. And if you're ready to accelerate your digital engineering mission, visit avl.com for more insights. Until next time, keep simulating, keep innovating, and keep pushing the boundaries.